and then share my screen. One sec. All right. So hopefully everyone can see my screen. Okay. Okay, so take a look at exercise 1. Now I'm having issues opening it up. All right, hold on one second. Okay. Okay. All right, so was everyone able to at least download your physiology data? Not necessarily import it into R. That's, we're going to do that today, but at least download it into a folder. Okay, perfect. All right, so the first question is, we're going to create a basic descriptive table. So remember, we talked about table 1 in lecture 2, and then if you look at the subsequent tasks in that question, we're going to start categorizing our variables. So, oh, okay. It wouldn't open for you. Okay, so it is a, I believe it's an SPSS data set, so it might not open, but you should be able to at least save it to a folder. Were you at least able to save the data set to a folder on like your C drive or, okay. Okay, let's see.
Actually, yeah, I'm not letting me save my data either.
Mine kept crashing my computer when I was trying to open it up.
It came up blank. Okay. Okay, let me see. All right, hang on one second. I'm going to go into, all right, let me stop sharing really quickly so I can go into Cougar Courses and see if there's a better way to, hold on, like if you can right click it or something like that. Let me just check real quick. Okay, if for those of you who are not able to download it, if you go into Cougar Courses and go to the exercise section, so let me know when you're ready. Okay, so for those of you who have not been able to download it, are you in Cougar Course? Okay, so now go to exercises. So that's just that second section, I think under introduction. And then under exercise 1, I have the physiology data set. And if you just right click on physiology.
Got it.
Yep, and then save link as, and then save it somewhere, for me, I have like a 503 folder and like exercises subfolder, and I'm saving my data sets and my R code there. So just save it somewhere where it will make sense, and then you can pull it from that folder when you're in R. Okay, that's interesting. It should be a save link as. And so when I click that, it opens up, for me, my default is my desktop, but just save link as, and you'll see, the file name is physiology and the save type is SAV. and then you can just save it where it makes sense for you. So April, do you have a save link as option? Oh, that's interesting. For those of you, so Alex, for example, did you have SPSS on your computer at some point? Oh, okay. Okay, maybe that's why. All right, let me think. Okay, if I were to email it, I wonder if you'd run into the same issue. Let me see. Okay, hold on. Okay. All right, so I'm gonna go into R really quickly. I know you can't see my screen. What I'm gonna try to do is pull in the data set and save it as a CSV file and see if I can send that out, like post it on Cougar Courses, and then you guys can pull that in. So hold on one second, just give me a sec. I'm in the waiting room. Okay, so, oh, okay. Sorry, April. Okay. No, it's not a problem. One thing I might have you do for those of you who have had SPSS, if you still have it on your computer, maybe uninstall it, just so you don't have any issues in the future if we are working with other SPSS data sets. But I do think moving forward, most of them will be text files and CSV files. So one sec. Sorry, guys, just hang tight. Let's see. Okay. Oop. All right. Test. Okay. Let's see. see if this works. The good news is we're going to be using this data set and like a small CSV file. So that's just like a comma delimited file from Excel for probably the next couple of weeks. So, oh, all right. Okay. All right, awesome. Okay, I have a CSV file. I'm going to post that to the exercise section of Cougar courses, and then hopefully that will work for you guys. All right, one sec. Okay. Okay. All right, so the CSV file is up. Go ahead, for those of you who don't have the physiology data set, go back and navigate to Cougar courses. And then right click on that physiology data set number 2, and then save link as. Let me download it to R and text edit. It should, oh, you don't have a save link as option. Okay, let me try clicking on it. Okay, if you just click on it, it will save it, probably to like a downloads folder, and then you can, let's see.
Can I share what happened with me? So it wasn't, so I was able to download it, and it wasn't like when I would click it, it wouldn't open. It kept giving me the option. It said either download or save, and whether I picked download or save, it kept just giving me that same little, yeah, it opened up to my internet browser also.
Okay.
So it wasn't opening, but then I went into my downloads and I saw the file there, and then I right clicked, and then I selected open with, and
okay,
then,
so don't open it, right click it and save it to a folder where you can, where it will make sense. So like a folder where you're going to do all your exercises. So like a folder for your class, for this class. So yeah, so if that happens, that's great. Go to your download folder, just copy it or cut it and paste it to another location that makes sense to you.
so I ended up, when I right clicked it, I put open with RStudio, and then now in RStudio, I see it in the bottom right quadrant. It's like a little file in there, and then
Okay.
from there it gives me the option to say install. So I don't know if that's like, is
Oh,
that
to like import it?
yeah, import it, yeah.
Yeah,
Is that
okay.
like good? Okay.
Okay, perfect. So you're all set up. So is everybody good? Like we're all good to go? And it doesn't matter if you have the SAV file or the CSV file, that's fine. We're going to import it into R, and then it becomes an object in R, and then we're going to manipulate it and then save that R data set. Okay, perfect. Awesome. Yay. Okay, this is real life. So please don't feel bad at all. This is totally, this is definitely real life. Okay. All right. Okay, so can everyone see my screen now?
Yes.
Okay, perfect. And okay, so now I think I am just gonna ask, like, if I do ask questions, if you don't mind, just saying them out loud. I'm working off of my laptop, so I might not be able to see the chat right away. So it'll be quicker feedback if you just say something verbally. Okay, so I'm guessing this is where, right, you're seeing your physiology data set?
Yep.
Okay, perfect. So I'm going to, okay, see this little broom here? This is a really nice, so like this console window starts to get really messy. So I just clear the console. It doesn't clear out the things that you've done. So if I push my up on the cursor, I can still see all of the previous code that I ran. So, so it doesn't, you don't lose any of that memory, but it does just clear console and make it a lot neater. So, okay, so if for those of you who have the CSV file or the SAV file, what you're going to do is just, you can click on it and then import data set. You can
How do
import
you
using,
how do you get the data set even there? Mine's not there.
oh, okay, so go, okay, what do you see here in your window? Maybe
Same
like,
as you.
okay, so wherever you saved it, so if you see, if I go to the home, it just shows what's on my R drive, I mean, sorry, my C drive. And then what I've done is on my C drive, I created a folder for this class and then a subfolder for the exercises. And then I'll probably clean this up later, but typically what I'll do is within a folder, I will have a subfolder for my programs, a subfolder for my data sets, just so that you don't have like a folder with, you know, everything in it. So you can see here, I have a separate folder for my R code and a separate folder for my data set. So in that data set folder, that's where I'm saving all of the data sets that we'll be working with. At least these are just for the exercise one.
Okay, because
So,
mine's in Excel, so I just don't know how to get it over here.
oh, okay. So from Excel, just save as and keep the format. It actually, if you save it as an Excel file, that's fine too, or I can pull that in as well. But just save as and then save it somewhere that makes sense to you. So if that means, you know, creating a subfolder for the exercises for the class, go ahead and do that. And then once you've done that, you should be able to then navigate to that folder in R.
Okay.
So let me know when you're all set. For everyone else, okay, just that was okay. So you can kind of see here, right? This is now, you know how in R Markdown we had chunks of code and it was grayed out. So each chunk of code was gray. So it was kind of nice because you could visually it looked a lot neater. But again, I think I still, after fiddling around with R Markdown versus a script in R, I prefer a script. But you're, you know, welcome to do whatever makes sense for you, whatever, you know, you prefer. So what I'm going to have you do, because I've already opened up my script, for everyone else, just go ahead and click on new file. Oh, excuse me. So you're going to file, new file, and then select, sorry, select R script. And that should open up a window that looks like this, and then it's just blank. Okay, awesome. I'm glad you got it. Okay, perfect. So is everyone good now? Everyone has this window here where you can click on one of the data sets. I'm going to click on physiology, and then I'm going to import the data set. You can do this with R code as well. It's just nice that you can also do a, you know, click point and click. So go ahead and click import dataset. And then you see that R opens up this window and it shows you a preview. So in this case, this data set only has 20 observations, 20 individuals in this data set. If it was like a 10,000 row data set or something like that, it would still just show you the first 50 entries. Import options. So here you're going to name your R object. And so it's not mandatory, but R is case sensitive. So when I work in R, I do prefer to keep everything lowercase, because if I wanted to call, that's not always true, but I'll tell you why. If I wanted to call a certain variable from R or a data set name, and I just forget that, one of the letters is capitalized, R won't recognize it. So just for ease, I try to keep everything in lowercase with just a few exceptions. So if you prefer to do that as well, just go ahead and change the name to physiology with a lowercase p. Okay, and actually, so the code preview is there, but you see how the P actually changed? Like, so when you put your cursor into that code preview, so this is the code that R is running behind the scenes of this click down option to import the data. So this is loading the library Haven, which allows you to then read in this SPSS data set, and then it's just asking R to view the data set. Okay, so now once you have that, you're going to click import. Okay, and you see here in your console, R has run that code. So it created an R object or data set called physiology with a lower p, and then it's asking R to view that data set. And that's what you see here in your source window. Okay, so I'm going to minimize the chat here. I'm going to close this because I don't need to see all that right now. And then if you look here in your global environment, the upper right corner here, so this is just the test data set that I created in order to export a CSV file. So you won't see that, but you will see this. You'll see the physiology object is now in your R environment. And it's telling you a little bit about the data set. So you have 20 observations. So remember, I mentioned there are 20 people in this data set, and you have 11 variables. So you have 11 columns, and each of those correspond to some measure in those 20 people. Okay. So is everyone good so far? Okay.
Is there a reason why I have 12 variables? I don't know what happened, but
You have 12. Okay. Can you click on it? Just click on the physiology data set.
Okay.
Do you have something unusual maybe at the end after the fat column?
Let me check.
Did you pull in the, oh, sorry, go ahead.
Not that I don't see anything now.
Oh, okay. Did you pull in the SAV file or the CSV file?
CSV.
Okay, so it may be something like I did.
Okay.
Interesting. Okay, this is a test.
Does it really matter or at the moment, or?
It doesn't really matter at the moment. If you run into issues, then maybe I can have you share your screen and we can take a look. But it shouldn't matter. Okay, one more. Mine doesn't have to. Oh yes, you're not going to have tests. That's actually the data set that I created so that I could output a CSV file to send to those of you who weren't able to access the SPSS file. Okay, no worries. This is our first dive into coding in R. So, one step at a time. This is I think for me at least, a big learning curve. So definitely, be patient with yourselves. Okay, I'm going to open up the exercise. Okay, all right, let's see. Okay, so can everyone see again exercise 1? the first thing that we're going to do is create a descriptive table. So that's kind of the ultimate goal of question 1. But in order to do that, we have to categorize and renumber some of these, recategorize some of these variables. And then before that, if you remember, I can't remember which lecture it was, but whenever you start working with a data set, it's always good practice to kind of look at what you have in your data. So the nice thing with this data set is it's a really small, it's just 20 observations with 11 variables. And when we view the physiology table, you can see all the columns very nicely. It tells you, that there's participant age, there's race, ethnicity, and it even has like a label for that variable. So it describes it in a little bit more detail. So we can look at it here in the viewer. So for example, this is a great reason why we want to understand what our data looks like and have a data dictionary that corresponds to our data. Because for example, we have this variable height. If you were to see these numbers, then you might automatically assume, okay, it's height in centimeters, but it's really nice that there's this label here attached to the variable that tells us that this variable was measured in centimeters, okay? And then for example, weight, that this variable was measured in kilograms. So those are all like the units of measure are all, it's important information, right? So what we're going to do as part of this exercise is calculate BMI. And BMI, the unit for BMI is kilograms divided by meters squared. So we know, the unit of measure for these variables, and then we can convert it appropriately. So like if this was in inches, for example, we would have to convert it to meters first before we calculated BMI. Okay, so, and then, grip strength, for example, it's in kilograms. And then, as you move to the right, you can see the description for these variables. So another way that we can do that is using the STR function, and I believe that stands for structure. So it's just kind of telling you, so if in your console, if you want to go ahead and type STR, and this is another nice thing too. So you see, as I'm starting to type physiology, R automatically kind of suggests, oh, is this what you're trying to do? So, so it's just a little bit faster. It's kind of like predictive text. Okay, so if you write STR physiology and hit enter, you should get this nice, let me try to open this up. Okay, you should then be able to see all of the variables that are in this data set. Okay, and then it gives you kind of a preview of what the values are for that variable. Okay, and then the label for that variable. So if you remember, when we looked at the data set, each of those variables had a label. So this is participant's age. And then this is just the way that variable is stored or formatted. And that's specific to SPSS. So for those of you who pulled in the CSV file, you might not see these. Okay. All right, and then the other thing that we can do to kind of get an idea of what our data set looks like, I don't recommend this if you have a data set with lots of variables, so a lot of columns of data, but because we're working with a small data set here, we can also look at the summary of this data set. Okay, so go ahead in your console area or in your source area like I've done up here, you can write it up here as well. Okay, and then once you have summary physiology, you can run that and it gives you a nice kind of summary of each variable. So for age, this makes sense, right? It's a continuous variable. It gives you the minimum, the maximum, the first and the third quartile, the median and the mean. And look, if you see here, the median and the mean are pretty close together. So that tells us that it might be normally distributed. Okay. For race and ethnicity, it treats it like a continuous variable, but that's kind of weird, right? Because it's a categorical variable. So we're going to fix that with our code later on. Okay, awesome. All right. So, and then you can just kind of look at all of the other variables. So again, like gender, right? It's a nominal, it's a categorical, it's nominal because it's not ordered. And that's just kind of weird, right? But it still gives you these, statistics. So yeah, sure.
Oh wait, can everyone hear me? Okay. So I had a quick question on the. Let me pull it up. So you know how on the top left, I guess quadrant 1.
Yeah.
You have the title, then you have your code where it has installed. So if we have the CSV file, we won't see that code, correct?
Up here?
Yeah.
Oh, okay. If you have your CSV file, this doesn't matter. This is actually, so when you open up a file and then new file and then R script, it should open up this window and it's going to be blank for you. The reason why there is text here is because I've written all of this out. So this is what I worked on over the weekend, was creating this script with the code that accomplishes all of the things that we need to do in exercise 1. And I'm showing it to all of you because this is your first time really getting into R. And so I think if we were to, go through and have like both of us have blank screens, it might not be as helpful to all of you. So if you want, as we're going through, so let me do this.
I guess my question is, can you have 2 folders open or two open and then?
Yeah, you totally can. So I'm going to open up. So you see now I have a new R script and it's untitled because I haven't saved it or anything like that. The same thing happens when you open up a new Word document, right? It's like Word or document 1 or something until you save it. So same thing here. So untitled 1, and that's just an untitled R script.
If we have code on one, can we run it on another?
Yeah, so if I have code in this new section here, I can totally run it. So let's say I do physiology and all of these objects are now in the current R environment. So it's in R's memory right now until we close it and say, no, we don't want to save our workspace. So it's currently in our workspace, which is why physiology pops up automatically like that. Then if I were to highlight this and do Control Enter.
Yeah.
Okay. So this is because this is a new variable that I create in this old one. But as we go through, you're going to be adding all of this code systematically. And so as we go through, you're going to create new race as well. Okay.
Yes. Okay, cool. Because I was just thinking if I could write the code like with you, and then if I could just Control Enter and then just follow along with you on two different.
Totally.
Yeah.
Yeah. Totally. Okay. Sorry. I totally misunderstood your question. Okay. And I'm going to close this and not save. Right. So as we're going through this code, do not feel obligated. In fact, if you write it down in your console, it won't save it when we close out and say, no, don't save our workspace. So as we go through this code, definitely, and I should have said it earlier, so I apologize. Feel free to write it up here in your source area. That way you can save this later. So you can see I've named it here exercise 1. And what you'll do is just, save as, right? And I think it'll open up, the icon so that you can save it and then save it as a script file in whatever folder you've designated for your exercises. Okay. And then I see Alex's data is in this section.
Yeah, I figured I'd just verbally say it.
Okay.
Sorry for causing so much issues here,
No,
but
it's totally fine.
so my data set, I got all the stuff to work in the console. So like when we did the mean and median, that stuff all popped up down there when I clicked.
Down here.
But like in the console area, but in the upper area where you have your coding, for the exercise, that is where my data is.
Okay, and does your data look like this?
Yes, that's what it looks like.
So close that out. So click that little X and then go to File, New File, and then select R script.
Okay.
R.
Okay, so now that
Okay.
area is blank.
Yes. Okay. Perfect.
Okay.
Awesome. All right. It's okay. It's totally fine. When I was first learning SAS, which is the programming language that I use now, and it was like SAS for mainframe, which probably ages me, right? And my supervisor at the time literally sat down with me for weeks, every day for a few hours, showing me how to code all of this. So I totally appreciate that. It's a huge learning curve. Even if you have used other programming languages before, I find R is great. It's very robust. But especially as we start to recode the variables too, it's just not always the friendliest. Especially because I think SPSS there's a little bit more point and click options. So it's just more user friendly. But the nice thing with R is you can manipulate it a bit more, and there's a lot more flexibility and versatility in it. So, and then as Dr. Armenta mentioned, it is open source, so it's something that you'll be able to use wherever you go. So, so hopefully all of this like struggle and pain is worth it at the end of the day. Okay, so first thing, what I'll have all of you do is go ahead and write these lines of code in your script area. And remember this green, the pound sign, and it turns the text green, is just commenting out that text. So that's the like official terminology. But what it just means is that anything after these pound signs will not be read by R. So even if I were to highlight it and hit Control Enter to run that line, R runs it, but it knows that I'm not trying to do anything. It's really just documenting what I'm doing below it. And you can even put like a pound sign here. If I were to say like, I'm installing Tidyverse. And I run that whole line, R knows that after this pound sign, I'm not trying to run code or anything. It's just a comment to myself. So go ahead and run, write out those lines of code in your script. And then you can highlight it, hit Control Enter, and that'll run those 2 lines. And you can see in the console, R is now going to install the package, Tidyverse. And then it's just kind of going to do its thing before it actually loads the package, Tidyverse, with that second line of code. Okay, so now it's done this. And it's still giving me warning messages, and it's probably because I was working in R yesterday with this updated data set, which I've already saved. So, so it might just be confusing itself, but you shouldn't see this warning message. Okay. All right. So this is just the, this is me earlier importing it without that drop and click. So just using code to import it. And then remember, we looked at the structure for the physiology data set as well as the summary statistics for that data set. And then if you recall, for some of the variables, even though it was categorical, because it wasn't saved as a specific type of variable in R treated it as continuous. So we're going to kind of go over that here. All right, so that first,
hold on. So we typed the hashtags and install tidyverse package.
So you have this. Okay.
And then okay, so I did 9 and 10 and then 11. We just type it in because nothing's really coming up for me. So
yeah, so just type it in your script. So it's going to look like library, and then as you start to write it out, it should drop down and you can just select Tidyverse and then it'll do that for you. And then just highlight it. I've already loaded it, so I'm not going to do this, but highlight it and then hit Control Enter. And you can also run that line of code using the button up here, but I find it faster to just highlight it and then hit Control Enter. And then you should see that it's loaded.
I have a quick question too.
Yeah, sure.
So I ran the install packages tidy in the Control Enter, and it keeps saying trying different URLs at the bottom. It says like
here.
downloaded 772 kilobytes and then trying URL, and then it's all red, and it's done it like 50 times now.
Does it look like this? Is it still going?
It's still going, yeah.
Okay,
It's like
so
it's got a
Okay, it should eventually, for some of these packages, I do also get like this long line of, trying to access the package, probably from like one of their servers.
Okay.
But it should eventually stop and then show you something like this.
Okay, cool. Thank you.
Uh-huh. Okay,
So
same.
I'm getting an error that says that there's no package called tidyverse.
Okay, okay, so first off, are they in quotes? Is your code in quotes?
Yes, it is.
Okay. So the other thing to try is install packages. Okay, and then usually it pops up on its own. Hold on, let me try this. No, okay. The other thing to do, if that doesn't work, and I think what I'll do for next week is maybe post my code. So I posted example code, but maybe what I'll do for next week is post the code that I've used for the first few questions for exercise 1, just so that you have that and you can kind of get at least through question 1. Okay, so the other thing you can do is go to tools. If you can't install it from the script, go to tools. Let me know when you're good. Okay, install packages. So click that, and then here under the packages window, go ahead and type in tidyverse. And remember, it's case sensitive. So TIDYVER, and it should show up. And then you can go ahead and click tidyverse. Keep everything as the default, and then click install. Let me know if that works.
Okay, it looks like it's doing stuff. It's
Okay.
Downloading stuff.
Okay, awesome. Once that is done, you do have to load that package. So you've installed it, but now you're trying to pull it into R. So once all that's done and you have, package successfully unpacked, then go ahead and type in library tidyverse into your script and highlight it and then control enter, or just run it here. Okay, is everyone good now?
Do I have to type library tidyverse twice for 11?
Oh, no. I just did that to show as an example. Sorry, there. Okay. Okay, so, and remember tidyverse is like a package of packages. Right, so it has all these other packages attached to it, which are commonly used. For example, we will eventually use ggplot. And okay, this says, okay, if you do get this message, it's because I've pulled in this dplyr package as well. And it's just telling me that in both, like in a package, in the tidyverse package, there are functions, filter and lag, that are also functions in another package. So it's just telling me that there's a conflict there. You can ignore that for now. Okay, so let's move on. We're gonna start with question 1, where it says create a variable that includes 4 categories. So remember, if we go back and we look at, and we can do this because it's a small data set, if we look back at race and ethnicity, we see that there are more than 4 categories for race and ethnicity. Okay, and in this case, there are 7. We also saw that in the summary. So if I scroll up, race, ethnicity, the minimum value is 1 and the maximum value is 7. That doesn't tell me necessarily there are 7 categories, right? It could be 1, 2, and 7, but it does tell me that there's a max value of 7 here. If I would go to back up here, let's see. Okay, and then up here too, you can kind of see there are 7 categories. Okay, and they correspond to, so 1 corresponds to white, 2 corresponds to Black, non-Hispanic, 3 to Hispanic Latino, 4 to Asian Pacific Islander. If I were to extend this a bit more, it would correspond to, I believe there's American Indian, and then there's like other. So what we're going to do is collapse categories 4, 5, 6, and 7 and just combine it into one category called other. Okay, and that's what exercise 1 is asking us to do. So first, sorry, so we should have done this. So go ahead in your script, and it's always good practice to remember to comment what you're doing with the specific line of code. So here I'm saying I'm going to create a variable with these categories: white, non-Hispanic, Black, non-Hispanic, Hispanic, and other. But first, I'm going to look at that variable. What does it look like currently? Okay, so physiology is our data set name or our object. The $ is just going to separate the data set name from the variable. So when I write this out, what it's telling R is I want to look at what this variable race ethnicity in the data set physiology, what does that look like? Okay, so go ahead and write that out in your source area. And then once you've done that, and remember, R is case sensitive, and these variables in the physiology data set already happen to have capitalized letters, so capital R and capital E. Once you have that, highlight it and hit Control Enter. Okay, and then that will actually tell you these are the different values within that data set. I'm sorry, within that variable, and each value corresponds to this group. Okay, so everyone's good, right? Okay, so now we're going to recode it.
Mine just showed up as numbers. I wonder if that's because I had the, yeah.
Okay, so if you were to scroll down a little bit, does it show this?
No.
Okay, probably because, did you use the CSV file?
Yeah.
Okay, that's probably why.
Probably why.
So when I imported this SAV file and then exported it as a CSV file, it probably lost some of that information.
Gotcha.
But that's okay. Your code will still run, and then we're going to add labels so that we should be able to see the final variable. Your final race variable should look something like this. Okay, so now what you're going to do is we're going to recode it. In base SAS, this is one way that we can recode a variable. So this is the name of your new variable. Okay, if you were to just write new race, it would create, R would create an object called new race, and then, do whatever arguments you have here. We want to make sure that that variable ends up in our physiology data set. So we have to specify the data set, and then remember it's separated by a $, and then the variable name. So physiology, $, new race, and you can see here I've kept everything lowercase. That's our new variable, okay? And then this bracket is now telling us, okay, so we want to take this variable race ethnicity, which is the original race ethnicity variable. When it is equal to 1, I'm going to set that new value for the new variable, the value for the new variable to 1. Okay, and then for the next line, it's doing the same thing, and it's just saying when that old variable race ethnicity is equal to 2, I'm going to set my new variable, new race, to 2 as well. And then the same thing for 3. And then now you can see here, so remember we have 7 values here, but we're collapsing everyone else into this other category. Okay, so we have the new variable name, the old variable name, and now I'm saying if it's 4 or greater, so in this case 4, 5, 6, or 7, recategorize that, I'm sorry, collapse those categories into just 1. And I'm giving this a value of 9. And this is just sort of my own my own habit. If it's an other category, I usually set it to a 9. If there, if 9 doesn't already correspond to a very specific category. So you can actually set this to whatever you want. You can also set it to 4, and then we're going to relabel it, and you'll know that 4 includes all of these other groups together. So go ahead and write this out into your source area, and then you can go ahead and run that. And then I might have issues, let's see, because I already have this physiology data set created and saved. Yeah, okay. You should not see this warning message. Okay. Was that enough time for everyone to type that out?
Yes.
Okay.
I'm almost
Still
done.
typing? Okay, I'll just wait. I'll give it another minute.
Did you say that we should see the warning message?
No, you shouldn't. If you do, I believe the reason why I'm seeing it is because I was already running all of this code last night and saved my data set as an R data set. It should be something that's still like an object in your R environment that you haven't like saved to your hard drive yet. So you shouldn't see a warning message.
Mine looks exactly like yours.
Oh, okay. Interesting.
So does mine.
Okay.
My warning message says unknown for like new race.
Okay.
Yeah, same.
Click. When you click on physiology, do you see this new column here that you've created?
Yes.
Okay. So you should be good. I am guessing maybe R wants like some other line of code above this as kind of to tell it that I'm creating this new variable, new race, rather than just diving in and creating categories for it. So I'm guessing that that's what that warning message is. So let me look into that, just because when you get warning messages when you're running your code, it can be annoying and then worrisome too. Okay, so you've all gotten it, but you are seeing this new race column, right? So
Yeah.
R has gone ahead and created that variable called new race, and it should be within that physiology data set now. So it should be in that last column because it's the most recent variable that you've created. I'll look into this, but I'm guessing R is wanting us to say, I'm creating this new variable called new race, and then go ahead and categorize them. And that's probably what the warning message is telling us. So for now, I would just go ahead and ignore it because R is still doing what we're asking it to do. Oh, okay. I'm going to save this. Okay. So before we go any further, so I'm glad that asked me to save it, go ahead and save your script as well. So that if your computer crashes for whatever reason, you still have the code that you've been working on so far. So I'll give you guys a moment to go ahead and do that.
I have a quick question about saving things and like organizing.
Oh yeah, sure.
How do you, because my data set is still like in the desktop
Oh, okay.
part.
Yeah.
And then also just like for saving this I want to make sure I'm saving it to the right place.
Okay, so on your, let's say you are saving it to a hard drive, or even if you're like on, you have like a OneDrive or iCloud or something like that, you can also save those there. But what in my case, so if you go to the bottom right quadrant and I go to home, that's my C drive. And then I've created this folder for this class. So you can go ahead and do that as well. And then you can actually create your own folders too. So if you want, you can create a folder for this class and then like a new folder and call it exercises, for example, and just save everything in there. So for example, this is like, for me, this is a bit messy. So I'll probably create a subfolder that, says like exercises, exercises PDF or documents, and then save them there. And then I have these separate folders for data sets and R code. And then that's where you can save everything. So the other thing you can do here is I'm in my exercise subfolder. If you click on more, you can say, set this as my working directory so that when you save things, you don't have to write out this whole like path name. You can just write, I'll show you later when we save the data set, you can just write out, the folder that you want to write it in. So, or save it in like data sets, and then R will automatically know this whole thing is your working directory. And now you want to save it to this specific folder, subfolder called data sets. So you can do that too. But that's how you can navigate away from your desktop. So if you want to go ahead and create like a new folder on your C drive and save everything there. I don't know if you'll be able to do that now because actually you should be able to, because you've imported the data set now. So it's just like a temporary, it's an object in R. So you should be able to, you'll be able to save the data set that we're creating, this physiology data set where we're creating new variables, you'll be able to save it. And you should be able to save your script as well to a folder that you designate. So, okay. So is everyone good with recoding? So now you've created this new race variable. Okay, so now we're going to add labels. So remember, the SPSS data set had these nice labels that tell us, because if we had a variable and it just showed us these values and we had no idea what those values corresponded to, it's really not helpful, right? And in fact, I believe this may have happened with, actually, let me just check, hold on. Okay, no, it did tell us. Okay, ignore all that. So the nice thing is it has these labels attached to the values, right? And that's good practice for any data set that you're working with, to specify something like that. So I apologize to the folks that are using the CSV file. You won't have this information, but we are going to create labels for these new variables. So the first thing that we need to do is because we're going to use this function apply labels, and it's in this EXPSS package, go ahead and install this package. So again, if you had issues installing tidyverse using code, you can go to Tools, Install Packages, and then look for EXPSS, and it should pop up. And then you can select it and install it here. And if I were to run that, a lot of you also might get this warning message, this R tools is required to build our packages. Ignore that. We're not going to build packages in this class, thank goodness. Okay. Okay. Once you have that, what we're going to do is, so we're saying we're applying labels to a variable in the physiology data set and in the new data set, right? The new object that we've already created. And then we're going to use this function called apply labels. And in the first argument in that function, we're pointing R to the data set, so physiology. And then comma, it will separate the next argument. And if you hit enter, your cursor should automatically go right under this P here. So if I were to do that, and that just keeps the code neat. It's telling R, okay, these are all the arguments within this function apply labels. So now I'm saying, okay, the label that I want for the variable, the entire variable, new race is, and I'm choosing to call this variable or to label it, it's the recoded race variable. Okay, and in the original data set, I believe it was race ethnicity. Let's see. In the original variable, it was participants, race, ethnicity. That was the original label for the original race ethnicity variable. Now I want to distinguish it. I want to say that it's recoded, because we have recoded it, right? We've kept the first three categories the same, but we collapsed the remaining categories into a single category. And so I'm trying to distinguish it now from the original race ethnicity variable. Okay, so once you have this argument written out, you're going to type comma and hit enter again, and it should bring your cursor under the N there. Oops. Okay, and then you're going to have, again, this is your variable name. And then here, this C is just, it's combining. So I'm saying this is all part of like one, it's technically it's a vector, but it's one series of labels. And so now I'm assigning this label to the value 1 in my new variable. So in my new variable, I now want anyone who has a value of 1, I am saying that they are white, non-Hispanic. And you can give it any label you want, right? It should be accurate, but you can actually write out if you want white, non-Hispanic. That's totally fine too. And then I've hit comma. You can have it as like one long string in a single line, but I think it looks a little bit neater when you have them all under each other this way. So go ahead and write out each label. So white non-Hispanic is for value of 1, black non-Hispanic corresponds to values of 2, Hispanic corresponds to values of 3, and then remember we collapsed everyone else into this other category and that value was 9, okay? And then we just close our parentheses. All right, so is everyone good so far? Go ahead and highlight that, and then you're going to hit Control, Enter, and then R will run it. It's all blue, so it's nice. There are no errors.
Can you just go a little slower?
Okay.
For the white non-Hispanic, for all the code in green, is that case sensitive as well? Do we want to watch out for that?
So that it's just a label, so it really doesn't matter because it's not really something that you'll refer to later. That is more like how do I describe it? It's like a title. So it's almost like the text that I put in here after the hashtag.
Yeah.
It doesn't really matter, but it is what you want your label to look like. So so I guess the answer is no. It's kind of up to you how you want to. Yeah.
I was gonna ask because all of mine is in green.
Yes.
In my
all of it? Okay.
Yeah.
You might be missing a quotation.
Yeah.
Everything's been working though.
Or comma, or parenthesis.
Okay, I'll look.
Okay. So I would, yeah, just make sure you have quotes around the label names, and then your commas outside of the quote too.
Woo.
Are you guys good so far? Sorry, I know it's a lot. After this race variable, we'll take a break, and we will stop at 11. And then what I will do is post the code that I have for questions 1, 2, and I'm sorry, for questions 1, 2, and 3 within exercise 1, so that you can kind of work on the second and third questions, and actually the rest of question 1 on your own, but have code to run it with. And that's probably how we'll do, especially in the beginning, where I will provide code for you. And then you can change things like this. If you want to write out, instead of just giving it an abbreviation, you can write out non-Hispanic. And so you can take the code that I give you and kind of, play around with it if you want. So, and then as the semester goes on, and you get more comfortable, then I'll start to send you, less and less like very specific, detailed code, and just maybe give you prompts if you guys need it. And then that way you'll start to become more and more independent in your coding. But definitely to start off, I think it will be most helpful if I send you my code. Okay. Okay. I am going to see if this works, okay? I'm going to copy my code and paste it here. See if that works. I know it looks gross on the chat, but copy and paste that message I sent to everybody and then see if that works. Oh, sorry. It looks like I accidentally sent it to just one person. Okay, I apologize. All right, try that. Copy and paste it into your source code and see if that works.
Mine says it could not find function apply labels.
Oh, okay. Did you install and load this package EXPSS?
I thought I did.
Oh, okay. No problem. So
I did like the same process. I went to tools and all that.
Oh, okay. So once you do that and install it, you'll also want to then load that package into R.
Oh, did I not load it? How do we do that again?
So you'll just type out library and then put EXPSS in parentheses.
Oh, so did that not work? I thought I did that. Let me try that again.
Okay, no worries. Okay, yours is still green. Okay, so so Alex, so I'm glad I worked for Amanda. Okay, Alex, once we go through these last 3 lines to finish out this race variable, you and I can chat and see. I haven't done this, so I'll try to get you to share your screen, and then I can take a look and see if we can figure that out. And this is really the downside of a virtual environment. It would be so much easier for everybody if we were all like in a classroom and I could kind of walk over to your computer. So yeah, I know it's a bit more of a struggle right now trying to do this virtually. But okay, so I know there are a couple people it's not working for, but we'll figure this out on the break. What I want to do first, okay, I have also used MATLAB. I think R, I do prefer R over MATLAB, I have to say. I agree. Okay, so we're going to write out physiology, the data set, and then our new variable and see what it looks like. So again, right, I can put these comments anywhere I want, but this is just documenting, okay, what does this new variable look like? So I'm writing that out, physiology, $ new race, control enter, and then it has like these, it shows me all the values and then the labels. But So remember when R did a summary of the data set and it did a summary of the race ethnicity variable and it treated it like a continuous variable, right? So that's kind of problematic because it's not a continuous variable. So what we can do, it's not necessary, but for me, I think it's good practice because it's setting the variable to its sort of appropriate format, is to then tell R, this new race variable that we've created, it's a factor variable. It's a categorical variable. And so when we do that, so the way we do that is we tell R, this is the variable name that we want to format as a categorical or a factor variable, is what it's referred to in R. And then do your little arrow, left arrow. And then now I'm using this function factor and I'm putting in the variable name here in parentheses. Okay, and that's going to make it a factor variable. So once you've typed that out, I'm going to just show you. Okay, so R has run that code. Okay, and now instead of showing me these numeric variables, it's showing me the values, and it now knows it's this categorical variable. And I'm sorry if I'm just rushing here. Let me just write it out here. Okay, so I'm in my console just to show you. So now when I write out a summary for this particular variable, it does treat it like it's a categorical variable, right? So now if you're looking in my console area here, now R knows, okay, this is a categorical variable. There are 6 people in the first group, there are 8 in the second group, 2 in the third group, and 4 in that other group. And so I just want to show you the comparison here. When I look at the original race ethnicity variable, and granted there were seven classes or 7 categories for that variable, R still it treats it like a continuous variable, right? So now that we've set this new race variable as a factor variable, R now knows it's categorical. So when we take the summary of that variable, the output that we get makes a lot more sense, right? Okay, so I'm going to pause there because I know that's a lot to take in. And like coding fatigue is definitely real. So even if you're comfortable and familiar with what you're doing, coding for, hours on end is incredibly exhausting. So let's just take like a 5-minute break. And then Alex, are you still having issues? We can kind of try to figure out what's going on with your code. Okay, so I think, how do I, if anyone knows how I allow somebody to share their screen, let's see. Okay, oh, new share.
I think for someone to share their screen, they have to be a co-host.
Oh, I see. Okay.
And I think you can go to participants and like hover over their name, and I think you can make them a co-host, or like go over their picture and there's like options.
Oh, okay. Okay. So Alex, I am going to make you a co-host so that you can share your screen and then we'll take a look. Does that sound okay?
Yeah, that's fine.
Okay. Yes. Okay. Okay, so you should be able to share your screen now. I don't know if I have to stop sharing in order for you to share your screen.
Oh yeah, I think you do, because I just got a message that says
okay, so
will stop.
Okay, so I'm going to stop share, and then you should be able to throw your screen up now.
Okay, let me just hit this. Okay, can you see it?
Yes. Okay.
Okay, let me expand it since
Okay,
now I'm
sure.
working on 2 screens. That's how you do it? Okay, yeah. So this is what I'm looking at.
Okay. So.
And I don't know why this bottom area for like the new stuff we were doing, why it's green, but now it's green.
Okay. So let's see. Okay. So after recoded race variable, you have a quote. Okay, so first thing I'll ask you to do is go to after your physiology data set KINE 5032, comma, put your cursor after this comma and then between the comma and new race. So this is on, so go down a little bit more. This is under your add labels.
Okay, so in this area.
Yeah. Okay, so now where your cursor is apply labels, yeah, put it right after that comma.
Okay, right after.
Okay, yep, and hit enter.
Yeah.
Okay. Okay, I don't know why you can tab it over, like you can just hit tab a few times so that
it's like lined up.
Yeah, okay, and I know it doesn't matter, so it will still, okay, go back one more. Go back one. Okay, stop there.
Okay.
So this is, it's just good practice so that visually it's a little bit easier to look at.
Yeah.
For you, and it's really for you or anyone, I guess, looking at your code later. Okay, but now scroll over to your quote after variable and delete that close parenthesis there.
Oh, maybe that's why this didn't work.
Okay. Okay, now hit enter. Okay. And then let's see. One. I think that should be good. So now you can put your cursor after the 1 comma for white non-Hispanic.
Oops.
After the comma. Yeah.
There it is.
Okay. Yep. And then hit enter. Okay. And then like tab over. Yeah.
Okay, tab over.
Yeah.
Like right here.
Yeah. Yep. Perfect.
And then do the same thing for Hispanic.
Mm-hmm.
Okay.
Okay. Okay, and then you can see if you look up at your 2 up there, there's a quote after it. Go ahead and delete that.
Okay. Oh, now everything's blue.
Yep, and then after the 9, you're gonna put one more close parenthesis.
Okay, so double. Whoop, where to go? Okay.
Okay, perfect. Now, okay, so did you see those red X's? So those all went away. So that's our telling you your code looks runnable.
Okay.
Okay, so now go ahead and highlight all of that.
Okay.
Okay, and then hit Control Enter, or the run button. That's totally fine too. Now it should run. Okay. So the reason why is because it was trying to finish up, you see in your console area, it was trying to finish up code.
Yeah.
Yeah, okay, so now in the console area, you have like, so if you scroll down in your console, you have that caret there. So that's like, it's okay. Ours, like, I'm starting fresh now. I'm not like trying to continue any code. So now hit run again and it should run this time.
Okay, it all looks
perfect. Yay.
Yay. Okay, so now that this got fixed, will my, the next layer of like coding that you just showed us, it will show up like black. Okay.
It should, yeah.
Alrighty.
Okay, awesome. I'm glad that worked out. Okay, perfect. I'm glad. So this is great because that probably is a very, it will be like a common thing, you know, in R where like it's a quote or you're missing a parenthesis. And like with the programming language that I use, I think I mentioned it last week, like if I forget a semicolon, then it causes issues down, you know, in my code. And again, this is exactly why I don't want to grade, you know, like I want you all to turn in your exercises and I want to be able to see that you've put effort into trying to code it and accomplish the, the task that you're being given. But in terms of like the actual code, like it would be a horrible thing to grade because I make mistakes in my coding too, as you're seeing like throughout this class, right? So, okay.
Regardless, thank you for the help.
Oh yeah, no, that's what I'm here for. Okay, so I'm gonna go back to my RStudio screen and then we'll just try to get through this height variable. And then what I'm gonna do is post this R code for everybody. What I have so far is the code that corresponds to questions 1, 2, and 3. And then what you can do is just copy and paste this code and then go through it. And hopefully, you can, and, definitely send me, questions if you have any, but go through it and it should make sense because a lot of what we did up here for the race variable, we're just going to do something very similar for the height and for the BMI as well.
I had a question on when you do Control Enter, does it matter? Because I know you can do. I've been doing Control Enter in front of the line of code, like for physiology. Well, for any of them, does it matter where the little cursor is for you to press Control R, or will it disrupt the function?
Oh, interesting. So I think if you do that, it will just run the line where your cursor is. So like if my cursor is here, for example, between the Y and the S, and I hit Control Enter, I think it will just run this one line. For me, because my eyesight is not great. So I just end up highlighting the entire line and then hit Control Enter. And then that's also useful, right? If you want to highlight several lines of code.
Nice.
So yeah, so no difference, but this is just my preference. And you'll find this, right? I think as you start coding more and more that you have certain, preferences for how you want to code things and how you want to, run things in R. So.
You go up like 10 lines for the physiology for your line 37.
Okay.
When you hit Control Enter, what does it do for you on the?
If I were to hit Control Enter here without highlighting everything.
Yeah.
Okay.
Okay,
so I get a warning. Yeah. Okay. Yeah. So just try highlighting the whole thing. See if that works.
Oh no, I still got it. Damn.
Oh, you did. Okay.
I'm confused.
Oh, okay. Did you already run this?
I did.
Okay. So the error is saying we're trying to put labels on a variable that's already a factor variable. And then your factor will be converted back to character. That I believe is okay. Let me see.
Hit Enter.
Oh, okay. So now it's like a different format for this variable. Let me see what happens if I try to run this again. Okay. Oh. Sorry. Let me see. Okay. So you did that and it looks like R still ran it anyway, but it just converted it back to a character instead of a factor variable. So that code still ran, even though you got this warning message. And then once you run that code, it will convert it back to a factor variable. And so that when you get your summary for that variable, you should again get this, excuse me, what I've just highlighted down there in the console area. So, so basically what I'm saying is if you just highlight all of that and run it, you should be good to go.
Got it.
Okay, awesome. All right, so let's just go ahead and get through the height because I want to introduce this cut variable, cut function to all of you. And then actually we'll see where we are for time. I do want to end it by the class by 11. So one thing is every other Tuesday, I actually have a meeting at 11. So like today, for example, we have a meeting at 11. Next week, if you guys want, I can stay a bit longer. I can stay till noon. If you want to work through your code with me here, that's totally fine. Today I want to end by 11, and also because I'm sure there's like a little bit of coding fatigue too. But let's get through, at least get through height, and if we have time, let's get through BMI as well. And then actually questions 2 and 3 are checking for normality and outliers. And I think I've mentioned this a number of times over the semester where, you know, the data management, the data cleaning, the recoding of variables, that portion of your work most of the time takes up like 80 to 90% of your time. And once you have a nice clean data set, it's very, quick to just run your analyses. So if this part feels slow, even when you're comfortable with coding, it's always the most time consuming, I feel like. So there's that too. But okay, question 2 is asking how many participants are taller than 5'9". And if you remember, when we looked at the physiology data set, height is currently in centimeters. So the first thing we need to do is determine how many centimeters corresponds to 5 feet 9 inches, so that we can then separate out individuals who are taller than 5'9". So all I've done here is I'm just using R as a calculator. So I'm first determining how many inches 5'9" is. So, 5 times 12 inches, and then adding the 9 inches. So that's going to be 69. And then multiplying it by 2.54 to tell me how many centimeters corresponds to 5'9". So you can go ahead and do that. You can actually just do it in your console area because it's not like we're saving the answer or anything like that. So what you should get is 175.26 centimeters. Okay. And then now what we're going to do is categorize or dichotomize in this case, because it's really just less than or equal to 5'9" or greater than 5'9". And so we're creating this dichotomous variable, and it's just going to indicate to us who is less than 5'9" and less than or equal to 5'9", and who is taller than 5'9". Okay, so here I'm going to introduce the cut function. All right, and the cut, so again, like if this cut function just is kind of gross to you as we go through it, then you can always categorize going back using the code up here. But I want to introduce this to you so that you have this as an additional tool, and if it does make sense to you and you like it, then you can use this function instead. The cut function is particularly useful when you have a numeric variable that you want to then segment out into categories. Okay, so very similar to the code that we use for new race, what you're going to do first is to specify the name of your new variable. So you want this new variable, and in this case, I'm calling it new_height, and I want it to be in this physiology data set. So I'm including the data set, $, the variable name that I'm giving to this new variable. And then have your little pointer arrow. And then this is the cut function. And now these are the arguments for the cut function. And this should actually be more like.
Could you copy and paste this code in also? Just because like toggling back and forth between Zoom and RStudio is kind of what's taking me such a long time.
Oh, right. Okay. So let's see here.
Yeah, I agree.
Where's the chat? Huh, I lost the chat. Oh, here. Okay. There. Okay. So go ahead and copy and paste that into your source area. And then I'm just going to go over how this function is working. Okay, so I am dichotomizing this numeric variable height, right, with it's capital H in the data set. So what I need to do is if I have two categories, I need to give it 3 points, right? So from this value to this value, that corresponds to category 1. And from this value to, sorry, for this value to this value, that corresponds to category 2. Okay. So I know that nobody is going to be 0 centimeters tall, but I can set that as my, my lower limit for this category. Then I'm entering my cut point, which we determined was 175.26 centimeters. I know what the maximum value is, like I can get that from R, but let's say you have like a huge, you know, you just want it to be anyone greater than 5 feet 9 inches is going to be in that second category. You can just put INF, which stands for infinity. So that's what I've done here. Instead of trying to go back and look at what the maximum value for height is in my data set, I'm just going to put infinity so that it's like anyone greater than 69 inches is going to end up in that second category. Okay, and in this second line, that is just labeling those two categories. So remember that first category, you want to put people who are less than or equal to 5'9". So that's just the label. You can put whatever you want in there. I don't recommend putting 5, you know, this like actual 5'9", because then it starts to confuse R with your quotes. So I just put 69 inches. You could put 5, you know, if instead you wanted to put 5 foot, sorry, 9 inches, you could do something like that too. Okay. And then in your second category, remember, it's just anyone who's greater or who's taller than 5'9". Okay. The third argument is where this is very important. So by default, this argument is right equals false. But because you want this, you want that first category to include this value. So you want it to be closed. You want it to be right closed. So that means the first interval is going to be 0 through 175.26 centimeters. So that first category will include this value. So you're going to put true there. And then the second category is going to be anything greater than this value through infinity. And if I put like 100, you know, 200 right here, it would include 200. So it would be anything greater than 175.26 through 200. If this was false, that first interval would be 0 to anything less than 175.26. So if this was false, this first category would actually be more accurately less than 69 inches. And then in the second category, it would be left closed. So it would include that value. So it would actually be more accurately greater than or equal to if this argument was set to false. Okay. And then again, the default is false. So we want to put true. Okay, and then when we run that and we look at what this new variable looks like, you can see there are 19 people who are less than or equal to 5'9", and there's 1 person who's taller than 5'9". Okay, how is everyone feeling? Are you feeling like we can finish out BMI?
Yes.
Okay, awesome. All right, so I'm going to copy and paste this code again. Thank you for making that suggestion. I appreciate it. Like anything that will make it easier for you guys, that's what's important to me. The last thing I want is you guys to struggle through this and like never want to do research again. So, okay. So let me know once you have that, just go ahead and copy and paste that code in the chat. into your source area. And then we'll go through this, again, applying labels to your new variable, and then we're going to use this cut function again. Okay, so once you've copied and pasted, now I'm going to walk through this. Okay, so remember, BMI is just kilograms over meters squared. And if you recall, when we looked at our physiology data set, weight was in kilograms, so that's great. We don't have to convert it from pounds to kilograms. And then height is in centimeters, right? So we want to convert that to meters and then square it. So what I'm doing here is I'm creating this new variable, BMI. And so this is one of the exceptions, right? I'm actually capitalizing BMI, but I'm keeping it all uppercase. Because I know that BMI stands for body mass index. So for me, it makes sense to capitalize it. You don't have to, you can keep it lowercase if you want, it's totally fine. So I'm creating this new variable called BMI in the physiology data set. Okay, and then have your little arrow here. I'm taking the original weight, so that's kilograms, right? So that's this portion. And then for this, and then remember your order of operations. So I'm using a lot of parentheses here, but I'm dividing the height by 100 so that it's now in meters. And then I put parentheses around it so that R does this portion of the operation first, or the equation first. And then I'm using this caret 2 to square it. So that's converting this to meters and then squaring it. And I put those in parentheses as well, so that it takes care of this portion of the equation first. And then now it's taking a weight in kilograms and then dividing it by meters squared. So that should give you BMI. Okay, now in this second portion, if you remember from the race variable, when we created the new race variable, we're just applying labels. So I want to, in this case, I'm not applying labels to the values of BMI because it's still continuous, right? So it would be impossible, or it could be done, but it would be long lines of code and it wouldn't make sense. So we're not applying labels to the actual values in this case. I'm just applying a label to this new variable that I've created, BMI. So I'm using this function, apply labels. I'm specifying the data set, and then I'm telling R, I want to call this new BMI variable calculated BMI. Okay. And now, since we know it's a continuous variable, it makes sense to look at something like the mean and the standard deviation, right? And I believe that's actually something that we're asked to do in the exercise. So I'm going to go ahead and run that code. And you can see here, it's given me the sample mean. So it's 20.1. And then the standard deviation is 2.1. So remember from lecture 2, the standard deviation, you can have the standard deviation of the sample, but you can also have the standard deviation for the, the estimate of the population standard deviation. And that's where we have the sum of squares over n minus 1. When we use the SD function in R, it is actually giving us the estimate of the population standard deviation, not the sample. And the sample would just be the sum of squares divided by n. And the reason why R does this is because it's really the estimate of the population standard deviation that we use in all of our hypothesis testing, determining the standard error to get our confidence intervals. So that's just the more useful estimate. So that's just a note there. Okay, that this isn't the sample standard deviation, it's the estimate of the population standard deviation. Okay, so now we'll go through this cut variable again, and then this time, so now I'm creating this variable called BMI cat, and cat is just short for category, within the physiology data set. And then now I'm using this cut function. So now I'm taking this BMI variable that I just created up above, and then I'm specifying the cut points, right? So the exercise is asking us to categorize individuals in our data set to underweight, normal, and overweight. Okay, so these are the cut points for underweight, 18.5, and then normal is greater than greater than or equal to 18.5 and less than 25. And then anyone who has a BMI of 25 or greater is overweight or obese. So if we wanted to include an obese category here, we would just put, we would put 30 here, comma, and then infinity. And again, the infinity is just, I want it to be greater than, this last value. So in this particular case for BMI, we actually want our intervals to be right open. So what does that mean? We want that first interval to include 0, and we know, no one is going to have a BMI of 0, but we want it to include 0 and then be less than 18.5. So we don't want that first interval to include 18.5. So because we want those intervals to be right open, we indicate here and right equals false in that argument there. And remember, false is the default. So if I were to delete this line, it would still run and give us the same result. But I think for this cut function, it's good to really just be very specific. We're specifying here that it's false. And then up here for the height variable, we were specifying that it was true. So again, I think it's just good practice for, for certain arguments to actually just spell it out. Okay, so, and then again, we want this next interval, so for the normal category, to include 18.5, so it will be closed on the left side, but open up here, so it will be greater than or equal to 18.5, but less than 25, and that will be our normal category. And then finally, for our overweight individuals, again, it's left closed, so it will include 25, and then it'll just be anyone greater than or equal to 25. And then here in this labels argument, we are labeling those 3 categories that we just created to underweight, normal, and overweight. And then again, here it's just specifying which side of the interval is open. And in this case, we want it to be false. And then here, I'm just asking all right, what does this new BMI category variable look like? So we're gonna run that. And then you can see we have in our data set 4 individuals who are underweight according to their BMI value, 15 who are normal, and then 1 overweight individual. Okay, so is everyone good so far? Let me just, since we have a few minutes, what I'm gonna do is go ahead and run through this last chunk of code. Okay, I'm just gonna run through this last chunk of code. We're going to create table 1. So this way we can finish out question 1. Okay, so the exercise is asking us to create a table 1 and stratify by gender. So stratify by male, female. In order to do that, we can use a function called table by, and that is in a package called Arsenal. So I'm just going to copy and paste all of this code here and send it to you in the chat. So, all right. So go ahead and copy and paste what I just sent through the chat into your source area. Okay, so here we're loading, we're installing and then loading this package Arsenal. And then we're creating this object called table 1, and you can name it anything you want. You can name it, you can name it whatever you want. Have your arrow pointing to this new object, table 1. And then here we're just using the table by function. Okay, for the first part of this, in the first part of this function, I'm specifying gender because I want the table to be stratified by gender. Okay, and then I use this tilde to then indicate all of the variables that are going to show up in my rows. So in this case, I am doing tilde and then the period just tells that function I want to look at all the variables in my physiology data set. And then this argument is just telling R, this is my data set. This is what I want to use to create table 1. Okay, so I'm going to run that line of code. Oh, sorry, because I need to run. So I got an error because I don't have my necessary package yet. So I'm going to install that and then load it and just wait. Okay, so it's now installed and I'm just waiting for R to load it, and now it's loaded and then it was able to run this function. So you saw the error, it could not find function because before installing this package and loading it, the function didn't exist. R doesn't recognize it. Okay, so now I've created this object table 1, and now we just want to look at what that table looks like. So we're going to highlight the first summary function. And you can see here, it looks really gross, right? Like it looks pretty nice up here. You have, we know that these are the males, these are females, and then it shows you everybody, and then it actually gives you a p-value. So for the continuous ones, and we'll talk about this later, for the continuous variables, it's running a t-test, and for the categorical variables, it's running a chi-square test. This looks pretty gross. So what we can do is then add this argument text equals true. And now look what it looks like. So now we have this really nice table 1 where it's got every single variable in the physiology data set, including the ones that we haven't really messed around with, and then stratified by male, female. And then again, you see, if you scroll down to these new variables that we created, because they're factor variables in R, and again, this is another reason why I think it's important to specify the type of variable that we have. It's telling R, this is a categorical variable. And so therefore, when it presents the new race variable, it gives us what makes more sense, right? It gives us the count of individuals in each category of race, and then the percent of that entire group. So there are 5 men who are Black, non-Hispanic, and that corresponds to 45% of the entire male subgroup in our population, okay? On the other hand, if you look up, so I'm going to just scroll up to this table, in the original data set, race and ethnicity wasn't set as a factor variable, and so R is treating it like a continuous variable, which isn't very useful, right? This is like pretty meaningless right here. So that's an example of why, for me personally, I think it's important to, to format your variables accordingly. Okay, so that's just a note here that I have in my code. So, notice the original race ethnicity, which is a character variable, versus the new race variable that we created and told R is a factor variable. Okay, so if you look up here, gender is not, it doesn't have label. So it's just, 1 or 2. And that's not very useful. Like if we were to present this, someone just looking at this table wouldn't know what this actually means. So what I've done here is I've just added labels to the variable gender. So I'm going to copy and paste actually all of this, and I'm going to send that to you. And you can just paste it into your source area. And then I'll just quickly go through. So again, we're using the apply labels function. We're specifying the data set. Gender is the original variable, and we're just labeling it gender. And then we're giving the individual values a label as well. So 1 corresponds to men and 2 corresponds to women. So if I run that, that will give it the variable itself and the values labels. And then now I can redo table 1. This time, what I'm going to do, instead of including all of the variables in the physiology data set, now I'm going to specify, I just want to look at the variables that we created up above. So I'm calling it again table 1. So this now, if I run this code, it's going to replace this line of code up here, the table by function. And then again, that first variable is specifying which variable you want to stratify your table by. And then include this tilde to separate that stratification variable from the variables you want to include in your rows. So on this left-hand side of the table. And so now I'm spelling it out for R. I'm saying, I just want to look at race. I want to look at height, BMI, and then categories of BMI. And those are all the 4 variables that we created today. Okay, and then I'm just indicating here that these variables are in this data set physiology. All right, so now I'm just going to run, these 2 lines of code. And now you can see we have this really nice table. Now this makes more sense, right? We have men here, we have women here in this column. We have race. We have the new height variable that we created. We have BMI, which was continuous. So it makes sense that it's presenting the mean and the standard deviation and the range. And then we have categories of BMI here. So here, R is giving us the standard deviation. And I'm just curious, which standard deviation is it presenting? Is it the standard deviation of the sample, or is it the estimate of the population standard deviation? So if we wanted to do that, we could just highlight this code. So this is the SD function, right? It's getting the standard deviation. And you can see it's 2.12, which corresponds to, it's the same exact value as the 2.12 here in this table. So now I know for sure that when the table calculates the standard deviation, it's calculating the estimate of the population standard deviation. Okay, which is great. That's what we want. Okay. So the final thing that we'll do is we're going to save the physiology data set. So whatever you named your data set, your R object, so like Alex, when we looked at yours, it was like physiology, for KINE 503. So you'll want to type that out and put that here. And then I have just data sets physiology underscore new. So this, okay, so let me close out this. My working directory right now is what you see here. Okay, so R already knows I'm going to go here into this working directory. Let me actually just set it. Okay, so all I need to do now when I write my path name for where I want to save this R object, and I'm calling it physiology underscore new. And then for the R data, this is just the extension. So it's just equivalent to if you're saving a PDF file or if you're saving a spreadsheet, it would just be XLSX. So in this case, it's capital R data. That's the extension for this file. And then let's see what happens because I've already saved it. Hopefully it runs. Okay, so it saves it. So now if I go into data sets over here, you can see the R data that I've saved. Okay. Are you guys okay?
No.
Okay, let me check out the chat. Okay, yes. Okay. Is everyone good up to that point? The nice thing now is that we've saved this data set, we can load it later on. So we don't have to rerun all this code up above. We can now just load that R data set the next time we open up R and then start working with it.
Did you run that line?
Yes, so I ran this line. If you're having issues, it's probably something to do with your path name.
Yeah.
Okay. So go into your, this will be the easiest thing to do. Go into this section here, the bottom right corner where you have your directory, and then go to the exact location where you want to save your data set. So in this case, I'm in the exact folder where I want to save this data set. So go ahead and do that.
Okay.
Once you've done that and you're in the exact folder, you're going to run this. So now, so R already knows you're in the folder that you want to save that data set in. And okay, so sorry, back a couple steps. Go to exactly where you want to save your data set. Once you've done that, click on this More button and then click Set as Working Directory. So that's telling R, instead of having to type out your entire path name here, R already knows that your working directory is whatever you've specified. So all you need to do now is just indicate this is what you want to save your data as. I think this should work. Okay.
Yeah, that did. Thank you.
Okay, perfect. All right.
And then I actually have another quick question.
Sure.
I've been like for a little bit, everything I run has like the last couple things on the console say other equals 9 and then 2 parentheses. I think that must have been some sort of something I did when I was writing the code, but it just keeps coming up at the end. I don't know.
Oh, is there like a caret or a plus here?
There's a caret, yeah.
That's okay. Oh,
it's not messing anything up. It's just like there each time.
It's just showing it up.
Yeah.
That's really weird. I'm not sure.
Okay.
Do you want to share your screen or are you?
I'm on Zoom on my phone, so it might not work, but I can just look back at it later.
Okay. Is everyone else okay? So what I'll do is I'm going to stop here. I'm going to take this code and send it to everybody, or I'll post it on Cougar Courses. And then you can take that code and then finish questions 2 and 3 on your own. Yeah, I need to work. Okay, totally fine. And then next week, what we'll do is we are going to start to talk about correlation, and that's starting to get into question 4. So yes, and it is recorded. So I am going to, so again, post this code that you guys can use to finish questions 2 and 3. And then I think this was good. I like writing out the script ahead of time, and then I can sort of copy and paste into the chat. And that way, because I think if you get the entire program all at one time, it might not be as helpful. So if we do it in like chunks together, it might make a little bit more sense, or it's just a little bit easier to follow. So I'm glad sorry, I didn't see who recommended that, but that was a great recommendation. So I'll just continue to do that. No, these exercises are not due before the next class. So, so we will probably take the next 2 weeks to try to finish the exercises in class, or at least get started on some of the questions, and then you'll work on your own to sort of finish. So for example, next week we might be finishing questions 4 and 5 in class, and then you might have to finish question 6 on your own. And then the third week we'll finish the rest of the questions. If we don't cover them all in class, then you'll do the remainder of them on your own, and then we'll turn them in. So it probably, we have 2 more weeks to work on this, and I'll definitely let you guys know, because it really depends like what pace we're moving at. And so if it takes a little bit longer or a little bit less time, that will sort of determine when I'll ask you guys to try to turn in your exercises. So yes, work on questions 2 and 3 this week outside of class, but I will post this code today so that you can start questions 2 and 3 with example code already. So you're not having to do everything from scratch. And I think that would be the most beneficial way to do this, I think, instead of trying to get you guys to do, code just ad hoc. So does that work for everybody? Okay, Awesome. So just a quick recap. I will post this code later today so that you guys can do question 1 if you haven't, if you didn't get through all of it on your screen, get through question 1 and also questions 2 and 3. And then I will post a pre-recorded lecture later this week starting to talk about correlation. And then on Monday, we'll just do a mini recap of correlation, and then we'll dive into exercise 1 and start with question 4. Okay, and then if anyone had any questions for 2 and 3, we can go over that as well. Okay, awesome. I appreciate everyone's patience today, please touch base. Feel free to send me an email if you have any questions or run into any issues that I can help you out with.
Thank you.
Okay. Thank you so much. Have a great day, everyone. Bye.
Thank you.